last lesson, we were looking at multiplying our brackets and simplifying the answers of two brackets multiplied together, so things which are squared or things that were cubed. We have to be able to work backwards as well and factorize certain algebraic expressions. The one that we are already familiar with is the difference of two squares. And this first one here, a squared minus b squared, can be factorized into a minus b times a plus b. And if you have any different variations on this with different things here and here, this pattern helps you to factorize these sorts of small polynomials. It's particularly useful later when we come to solving equations with polynomials, because we have to be able to find the solutions, and the solutions are found by factorization. It's especially difficult if they are long and complicated. But if you can spot patterns, if you're aware of these patterns, it helps you to find out the different bracket sets and therefore solve equations later on. There's a special pattern here where you have a cubed plus b cubed. This can be factorized into two separate brackets that look like this. It doesn't match, it's not all positive, but it does have a certain pattern. It looks like this. If you multiply this bracket by this bracket, you get your a cubed from here, you get your b cubed from here, but in the middle you have a times this, which gives you minus a squared b. Then you have the b times this, which gives you minus ab squared. But you also get a positive version of both of those from this times this and this times this, and everything cancels each other out, and you're only left with these two things. So if you know this pattern, you can factorize it into these two brackets. In a similar way, a cubed minus b cubed can be factorized into a minus b times a squared plus ab plus b squared. And these three patterns can help us factorize things like this. This one is clearly the difference of two squares. It's more complicated because it's got 16 and 144, but you can think of this as being 4a all squared minus 12y all squared, which means we can stick that into two brackets. We'll have the 4a minus 12y and 4a plus 12y. It fits this pattern, the a squared minus b squared, and that's something that we've already come across when we were solving quadratics previously. These ones, they're less obvious, but we have these two new patterns. The fact that a cubed plus b cubed can be factorized into a plus b times a squared minus ab plus b squared. And that means here, instead of having an a, we've got this whole thing can be broken down into 2z all cubed. I have to cube root both of these things, not just the z. 8 is the cube root, 2 is the cube root of 8. Here I've got a cubic as well. I've got 5 cubed is 125. So I can think of this as being 5p all cubed. And now it looks like this. I can then break it down into these two brackets. This is going to be useful not just for solving equations, but for doing long division later on. Let's just see what happens. So this is my a and this is my b. So my final answer, my final factorization would be 2z plus 5p multiplied by this squared. 2z times 2z is 4z squared, minus a times b, so that's minus all of that times all of that. That'll be 2 times 5 is 10. Then I've got a zp plus b squared will be all of this squared, so 5p times 5p is 25p squared. So all I'm doing is I'm using this pattern to help me simplify this expression, or at least factorize. It's maybe not simple, but it is taking this expression and putting it into two brackets. And this is going to be useful for simplifying division sums next lesson. This one is following the pattern of a cubed minus b cubed. And the pattern for that one is a minus b times a squared plus ab plus b squared. So my a and my b here, that's nice and simple. That's just the same as my a. But this one can be written as being minus 3y all cubed. 27 cube rooted is 3. So my b is 3y, my a is just x. So I've got x minus 3y. Following the pattern I've written down here, I've got x squared plus x times 3y. And then b squared would be 3y squared, which is 9y squared. I could probably write that a little bit nicer by saying it's x minus 3y times x squared plus 3xy plus 9y squared. So these three patterns can help us put expressions back into brackets and therefore simplify expressions later on. There's some work for you. Good luck.